Okay, ready? Okay, right. See, yesterday's class, we just started with this very important topic called as what? Cyclone. A cyclone is important both for your prelims as well as mains examination. This year alone, you remember 2 questions they have asked from cyclone alone. Okay, right. And not only, say for example, this particular examination, any examination you take it, there can be n number of questions that can be asked in what? Cyclone. What we have covered is only a very small bit of cyclones as such. Okay, now, what exactly is a cyclone? We have classified, somewhere we have defined it, differentiated it. Okay, and at least 2 different types of cyclones we were discussing about. What are the 2 different types of cyclones we have taken? One you call them as what? Tropical, and 2 you call them as what? Temperate. So name itself gives you an idea that where exactly the cyclone will be occurring. Tropical cyclone occurs where? Tropical region. Approximate latitude also we said. Though I say tropical region, technically speaking, what is the, say for example, northern and southernmost limit of tropical region? It is all about Tropic of Cancer and Capricorn. But geography always we used to say that do not mark or demarcate any lines of limits. Okay. So practically I can take it, say for example, 5-10 degree beyond that so-called limit. That's the reason we said tropical cyclones may occur anywhere between 35 degree north and 35 degree south. But only exception we said equatorial region we may not have cyclones. So what is the reason for it? It is all because of absence or very weak Coriolis force. Right at equator, Coriolis force is absent, but equatorial region, Coriolis force is what? Minimum. What you said is perfectly right. Apart from tropical cyclones, we also talked about temperate cyclones. So both the cyclones are associated with low pressure, right? What exactly is that low pressure, which eventually results in the formation of tropical cyclones? Somewhere we say it is all about what? IT season. What about temperate cyclones? It is all about what? Subpolar low, right? That low pressure, what you experience in the mid latitude, you call them as what? Subpolar low. Okay. So we have differentiated between tropical and temperate cyclones, and the tropical cyclone in detail we talked about. Okay. So we talked about tropical cyclone, how exactly we define a cyclone. Indian classification, which itself we have taken from WMO's classification. Somewhere we said any sustained wind velocity which has a velocity of more than 63 kilometers per hour, you call them as what? Cyclones. Okay. And I told you that word sustained. When I talk about sustained, how many minutes this wind should be flowing continuously? It is 3 minutes. But however, when I talk about other scales, particularly when I talk about US conditions, right, instead of 3 minutes, that sustained wind velocity they have taken for what? 10 minutes. So we'll not go into the details of it. That much technicality is not needed. Only thing is that continuously this wind should be flowing, okay, or blowing. And somewhere we said, what are the preconditions needed for the formation of tropical cyclone? Somewhere we said high temperature. To be very, very precise, I'm talking about what? Sea surface temperature. Whatever the temperature which is there in the upper layer of this water of the ocean, I call them as what? Sea surface temperature. And according to NCERT, it says that it should be more than 27 degrees centigrade. And NCERT also says that the size of the sea should be comparatively what? Large. Okay. And of course, we also said that it needs high amount of moisture. Again, why I'm including moisture here? Because any water vapor you take it, right? Any moisture, water vapor you take it, water vapor will always have what? Latent heat in it. Or you make it very simple, right? Our body has, for example, right, somewhere if you're feeling very hot, what exactly is the defensive mechanism body does? Will be sweating. Right? If you're sitting under a fan, say for example, slightly you'll be feeling cold, right? What exactly makes your body slightly cold when you sit below this fan? What is the reason? When sweat evaporates, what exactly this evaporation of sweat does? Whenever the sweat is evaporating, it is almost taking your body heat along with it. So what I want to tell you, when the sweat is evaporating, when the sweat is becoming moisture, right, whatever the heat that is removed from your body is stored inside or within this moisture as what? Latent heat. Any hidden heat, you call them as what? Latent heat. That's the reason we say any moisture or water vapor you take it, always you'll be finding what? Latent heat in it. Am I right? So this latent heat will be further intensifying this cyclonic circulation as such. Okay. Now, apart from that, what makes it as a circulation? We said it is all because of what? Coriolis force. Okay. If Coriolis force is not there, the wind which is moving towards the very, say, for example, center of this low pressure, very easily it will be merging with each other and this low pressure will cease to exist. Just because Coriolis force is there, it makes a circulation. What happens? This wind is not able to, say, for example, almost merge with what? this low pressure at the center. And I also know the fact Coriolis force increases with increasing latitude, and it also increases with what? Increasing velocity of wind, not altitude, velocity of the wind. If you increase the velocity of the wind, what happens to the effect of Coriolis force? It increases. Though I say it is very, say for example, assume that it is happening in tropical region. The effectivity of Coriolis force is not so great in tropical region comparing to temperate and polar regions, but still Coriolis force makes it as a circulation for the simple reason velocity of the wind is what? Very, very high. Okay. And I also said no cyclones will altogether form from nowhere, right? Somewhere a pre-existence of a depression should be there. Okay. So we talked about the precondition needed for the formation of the cyclone. And accordingly, we said only 7 regions are there in the world which is known for cyclonic surges. See, cyclone or the so-called low pressure can have their genesis in the open ocean. But whenever I talk about this depression or low pressure becoming cyclone, that is confined only to what? The marginal water bodies or this enclosed water bodies of the ocean, right? Only 7 such water bodies we have taken it. But I told you that different regions in the world, the cyclones are referred by different names. Indian Ocean region, you call them as what? Cyclones. American region, normally you call them as what? Hurricanes. East Asia, you call them as what? Typhoon. And Australian region, you call them as what? Billies, right? That's how it goes. Okay. We talked about the structure of the cyclone, right? Before I came today, again, somewhere I was of the opinion that you were also talking about the structure of cyclone one more time. Okay. And when I talk about the structure of cyclones, so the very important character we have taken. Any tropical cyclone you take it, the very center of the cyclone, we have what? I. What regulates the entire mechanism, you call them as what? I. But we told somewhere we have taken one very important character of this I. This I is nearly devoid of any wind and precipitation. Somewhere we said it is known for what? Absolute calm condition that is prevailing. So no wind, no precipitation. Okay. So why there is no wind, if you ask me, it is all because of what? Convection. I told you, at any given point of time, at any place, only one process will take place. Either convection will be taking place or advection will be taking place, right? So same place, I will not have both convection and advection taking place together. What is advection? Other name for what? Wind. Right? So wherever there is a vertical movement of air mass, I may not have what? Then comes the question, why exactly? Okay, why no wind, I understand, but why no precipitation? Why no rainfall? Because within the eye, what dominates at the center of this eye is what? Subsiding convection. See, rising convection I do have. I'm not denying the fact. But rising convection is predominant in which side of this eye, if you ask me, only near what? The eye wall, right? Somewhere I have this rising convection. Otherwise, predominantly, if I'm there at the center of this eye, what dominates is what? Subsiding convection. Subsiding convection will be resulting in what? Dry conditions as such. Okay. Now I told you, the highest velocity of the wind and very heavy precipitation will be starting from where? From eye wall. And as you move away from the eye wall, what happens? The intensity of precipitation and the velocity of the wind will be decreasing. Okay, so we talked about the structure of cyclone, right? And again, how exactly cyclone comes to an end, that also we discussed about, right? And I also told you the direction of cyclonic circulation. See, any moving unstable mass, you apply the effectivity of Coriolis force. Northern hemisphere, it will be clockwise, right? Southern hemisphere, it will be anti-clockwise. The only exception to this phenomena is what? Cyclone. Correct? For example, when I just talk about whirlpool, right? Circulation of this localized water, you call them as what? Whirlpool. If I just talk about oceanic currents or ocean currents, everywhere you'll be finding northern hemisphere, the circulation will be clockwise, and southern hemisphere, it will be anti-clockwise. Why? Number of times I said, right? Deflection towards right, and right in northern hemisphere makes it what? Clockwise. But cyclone is exception to it. That is also because of Coriolis force, but the indirect effect of Coriolis force. Accordingly, we said, when I just talk about cyclones of northern hemisphere, right, which direction they circulate, it is counterclockwise in direction. I told you this particular fact is very, very important. If I remember this one fact, I can remember almost all the facts. For example, what will be the direction of cyclones in southern hemisphere? What will be the direction of anticyclone in northern hemisphere and southern hemisphere? All the facts I can remember, provided I just take pains to remember only one particular fact. I repeat again. So what will be the direction of cyclones or cyclonic circulation in northern hemisphere? It'll be anti-clockwise or counterclockwise. Okay. So what I just wanted to show you, if I just talk about circulation mechanism of any wind, if you are there in Northern Hemisphere, you'll be finding largely this wind will be circulating in what? Counterclockwise in direction. Somewhere you can find it. This is a real-time satellite image. Okay. If at all, if I'm just moving to Southern Hemisphere, you'll be finding that this, okay. So if I'm there in Southern Hemisphere, normally I'll be finding that any wind circulation will be what? Clockwise in direction. Okay. Fine. Now, everything about cyclone we have discussed. Okay. Including the direction of its circulation we have just discussed. And before completing yesterday's class, I've also told you that how exactly cyclones are named. Why exactly cyclone is named and how exactly cyclone is named. When I just talk about this, why exactly cyclone is named, I told you only one reason for it. What is the reason for it? Disaster mitigation, just to somewhere facilitate what? Effective communication. So if at all, if I have a name and that name, if it is a simple name and a common name, communicating regarding or communication regarding this cyclone can be what? Very, very effective, right? It can reach the targeted, right? Almost the people who are likely to get affected as such.
Veranda IAS, where your dream becomes reality.